I wanted to do a quick lesson about normals and tangents. So what is a normal? Not what is normal, but what is a normal? So a normal is a line which cuts another line at 90 degrees, perpendicular. The concept of a normal becomes really, really important next year in calculus. It's also really, really important when you start investigating physics. Often the only time you can identify a plane is by the normal to that plane. All right, so for this one here, I'm going to start off early, start off easy, I should say, and I want to find the normal, or this graph here, at 1, 1. So I've already given you one point. So in other words, I want to find the gradient of the line that cuts this line at 90 degrees, is perpendicular. So how would we go about doing that? Well, we need, in order to find the equation of a line, we need two things. We need the gradient of that line, m, and one of the points at the least, or two of the points, in which case we would find the gradient. What is the gradient of this perpendicular line? Well, we have a little formula, m1, m2. When we multiply them together, we get -1. m1 is the gradient of the tangent or the line, and m2 is the gradient of the normal. All right. Quick way of doing it though is, if the gradient of this one, and I'm going to show you straight away, it's 2. It's 2 over 1. So the gradient of the tangent m1 is 2 over 1. The gradient of the perpendicular, or the normal, m2, is going to be -1 over 2. The way we get there is if we know the gradient of the tangent in this kind of rise over run form, what we do is we flip it. So the numerator becomes the denominator and vice versa, and multiply it by -1. So if we had a tangent, the gradient was 2 over 3. The gradient of the line which is perpendicular to that, the little symbol there, the upside down T, means perpendicular. It looks like a right angle, is going to be 3 over 2, but -3 over 2. Okay, so if m1 is a over b, m2 is going to be -b over a. But quite often, in fact, the ones we're going to do next, you can't really do that very easily. So you have to sort of rely on this formula here. Well, therefore, we know that the gradient of this line here is -1 over 2, and we have one of the points, so therefore we can find the equation of that line. So y1, y minus y1 equals mx minus x1. So y minus, and one of the points is 1, equals -half x minus 1. Let's bring that -1 over. So it's going to be -1 half x plus a half plus 1. Because -1/2 times -1 is positive half. So the formula of this line here is therefore going to be y equals -1/2 x plus 1.5, or 3/2 if you want. All right, so everything that you need to know about normals is in this little example here. But let's do some trickier examples. So for this example, we want the tangent and the normal where x equals 2. So in other words, we want the tangent to that line, which is going to be kind of there, and the normal to that line, which is going to be kind of like there, like that. How do we find the tangent? Well, we need to find the gradient, and it's where x equals 2, and we would need to find the y value where x equals 2, and I'm just going to give it to you. It's at 4. It's at 2, 4. I'm just going to cheat for now. So to find the gradient, we need to differentiate y with respect to x. So it's going to be 3x, the 3 loses 1, becomes a 2, minus 2 times -2 is minus 4, x, and the 4 disappears. Now we plug this x equals 2 in here to find the gradient. So that's going to be 3, 2 squared, minus 4 times 2. So 2 squared is 4. Times 3 is 12, minus 8. So the gradient, therefore, is going to be 4. Therefore, the gradient of the perpendicular, the normal, is going to be 1/4 times -1, so -1/4. Okay, now we have 1 point and we have the gradients. So the tangent is going to have the form y minus y1, and y1 is going to be 4. It is going to be equal to 4x minus 2. So y is going to be equal to 4x minus 8 plus 4. So that means this tangent line here is going to have the equation y equals 4x minus 4. Okay, now we want to find the equation of the normal line here. Well, we know one of the points is 2, 4. In fact, that's the point that we're using, and the gradient is minus 1/4. Same process as before. So y minus 4 is going to be equal to minus 1/4 x minus 2. So y is going to be equal to minus 1/4 x plus half. -1/4 times -2 is half, plus 4. So the equation for this is going to be -1/4 x plus plus 4.5. 4.5. So it's gonna, maybe I was a bit optimistic. It's gonna cross it around about there somewhere. This is gonna rub out for me. Nope. Plus 4.5. I'll rewrite it. And just by inspection, yeah, that looks about right. Bit messy, but it's right. Now this funky looking graph here, is this equation y equals 4x power 4 minus 3x cubed minus 2x squared minus 1. And I want to find the tangent and the normal where x equals -1. So this is x equals -1 here. And I'm going to say that it's 4. Let's actually prove it. So 4, -1, 4 minus 3, -1 cubed minus 2, -1 squared minus 1. What does that equal? I'm pretty sure it's 4 looking at it, but let's make sure. So minus 1 to the power of 4 is -1 times 4. -1 to the power of 4? No, that's not -1. No. -1 to the power of 4 is 1. So 4 times 1 is 4. -1 to the power of 3 is -1. So -1 is going to be plus 3. -1 squared is +1. +1 times -1 times -2 is -2. And minus 1, that's going to be 7. Minus 3 is 4. So it is 4. Wow, that's a real bug on these SEO emulators. Okay. I know that because the -1, when you square it, it becomes positive. When you raise it to a negative power, it stays negative. Still, okay. So we know that the point -1, +4 is the point that we're looking for. Now we need to find the gradient of the tangent line. This kind of line that's tangent to that, where x equals -1. So we need to differentiate it. Differentiate this one here. So 4 times 4 is 16x cubed. 3 times -3 is -9 x squared. 2 times -2 is -4 x, and the -1 annihilates. And then we're going to put -1 wherever we have an x. So 16 -1 cubed minus 9 -1 squared minus 4 times -1. So -1 cubed is -1. So -16. -1 squared is +1. +1 times -9 is +9. And -1 times -4 is +4. So that means that the slope here is going to be 16 minus 13. So it's going to be -3. Therefore, the gradient of the function that cuts it at 90 degrees, so if m is -3/1, the gradient of the perpendicular must be 1/3, but positive 1/3, because we multiply it by -1. All right, we're getting there. So the equation of the tangent has the gradient equal -3, and it goes through the point -1, 4. So y minus 4 equals -3 x plus 1, and we'll take the -4 across, is -3x -3 plus 4. So it's y equals -3x plus 1. And the equation for the normal, the line that cuts this line at 90 degrees, is going to be y minus 4 again, equals 1/3 x plus 1. So y is going to be equal to 1/3 x plus 1/3 plus 4. So it's going to be y equals 1/3 x plus 4 1/3, and we're done. That's how we do normals. Again, if you've got any questions, just send me a message or leave a comment, and I'll get back and